Assalamualaikum warahmatullahi wabarakatuh and good afternoon everyone. Afternoon.
Waalaikumsalam, good afternoon.
Good afternoon, sir.
Okay. All right. Today, at the moment we are joined with Dr. Hazrina's class as well. I think Dr. Hazrina is here as well. Because I because we are going to brief you on the group project, right? Group project. Okay. I guess let's just record start the recording first. Okay. All right. I'm going to brief you. Okay, the project description. The project for your group project. Okay. So I'm not so sure. This one it's on Spectrum already, right? Dr. Zarina?
Yes, I have uploaded.
Okay. So you can find the group project description on Spectrum. Okay. So basically, I guess all of you have been assigned to a group. So I'm not so sure. Like for my group, I have I sorry. So for my group, I think all of the students have their group already because we already done our lab viva. Okay. Basically, what we're gonna do for our group project is, if you see here, we are going to do some project-based group project. Okay. So basically, the learning outcome for this is that we are going to, have a utilize all the chosen tools. So for our group project, we're still going to use Python. It's just like what you do for your lab one. And then you're going to apply algorithm onto several given problems. Okay, so most of the algorithms will be, I think most of the algorithm we will be learning in class, or we have learned in class. Okay, and you are also allowed to maybe suggest or apply a different algorithm as well, other than the one that we learn inside the class. Okay, and then we yeah, and you are encouraged, okay, to explore at least one new algorithm. And specifically for this semester, we added one problem whereby you will have to look into one new algorithm that we are not going to be covered in class. So we're going to see that later on. Okay, and then you have to integrate all the algorithm to basically solve a given problem. You need to execute the computer program, so you have to present it during your group presentation. Okay, in week 14, I believe. And basically, what you have to do is you need to explain the relation in steps between in the algorithm, as well as what are the behavior and the output of the computer program. Okay, you also have to do running time complexity analysis of the of whatever implementation that you have done. Okay, for to solve the problem. Particularly for your group project, we will be assessing in terms of your group work. Okay, in the end, you'll be given a form to fill where you'll be assessing all your peers, okay, all your members, as well as you need to do some effective communication through the report as well as the presentation. And I think you also need to, do some group contract as well as the filler form, okay, for your group. So basically, what you have to do is that you have to solve a problem. We will give you a set of problem. Okay, you and your teammate need to analyze, design, and code a program using Python. And the tools, I leave it up to you if you want to use PyCharm, or I believe I saw some of you use Jupyter IDE. So it's up to you what kind of IDE you want to use, but you have to implement it using Python. Okay. So the scope, I guess most of this we have fulfilled. Okay, a work of 6 members. Some group may have 5. Okay, and I believe most of I think all the groups will have one team leader or team representative, whereby you need, I think by this week, by end of this week, you have to submit group contract. Okay, as well, whereby in the group contract you have to identify what are the roles, responsibility. Okay, and you know what are the tasks that you're supposed, as well as this filler form. Okay, whereby you specify what are the responsibility and what are the tasks that you have to do as a group member. Okay, and basically what you have to do is that, okay, so for our group project we have 4 problems. We have given 4 problems. Okay, so maybe we can go through the problem one by one. Okay, and if you have any question, please let me know. So for problem number 1, so basically this group project is about courier services. Okay, delivery services, where you need to analyze, what are the best courier services that you can choose. Okay, in order for you to deliver an item, let's say for example. So in problem 1, um, um, so here, if you see customer who needs to make delivery needs to know which courier company can does it fast, assuming that the shorter distance, the quicker is the delivery. Okay, so you need to develop an application where, and here you are given 5 local courier companies which have their delivery hubs located in various locations in West Malaysia. Okay, so I have here you can see that we have given you the details of the courier company as well as their hub location. All right. So so as you can see here, the hub locations are fictional. So probably when you plug in these coordinates into your Google Map, you probably will get some random warehouse. But assume that as the hub for each of these courier services. Okay. And then what you have to do, you need to get and mark all the location given in table 1. So as you can see here, we give you several guide that you can use for this project. But if, like, let's say you found out there are other tools that you can use for the this, like for my group, I'm sure for the Tanzina's group and Dr. Raja's group, I believe we allow, like if you want to use any other tools, if you find any other tools that is possible for you to do this. Okay, and then for the second thing that you have to do, given these 3 customers. Okay, again, you are given the origin coordinates as well as the destination coordinate. Okay, for delivery. Okay, for 3 customers. So given this information, you need to you also need to, okay, um, um, uh, plot the location as well as find the distance. Okay, find the distance between these 2 points. Okay, so that would be the first step. And then looking at part 3, okay, assuming that all deliveries must go through the delivery hub. Okay, for example, if you have a delivery from Kuala Lumpur uh, uh, to Putrajaya, let's say for example, and you want to use Post Laju, so it has to go through the Post Laju hub in PJ. So it will be from origin to the hub and to the destination. And then you have to plot this on the map, and you need to try to compute what are the least distance that the parcel have to travel for each of the customer using every courier company. Okay, so you will have several routes for delivering the parcel using different courier company for each of the customer. Okay, so as I mentioned, you need to plot this the line onto of this before which is the one that you do without going to the hub, the least distance between the 2 points. And after you have applied some algorithm that you have developed in order for you to find what are the least distance that the parcel have to travel for each of the customer. Okay, so that would be in part 4. Okay, that will and then in problem 2, you have to add in some sentiment analysis, because as you can see here, shortest distance travel does not mean that the current courier company is recommended. Okay, and therefore you need to do some kind of sentiment analysis for each of the courier company Okay, so for in part 5, you need to find 3 articles, okay, any kind of articles that is related to the courier company online. So try to get article from a very from a good source, like let's say for example news websites, okay, or any publication in regards to like reporting about the courier company. And then you have to do sentiment analysis on it. Okay, so these are some of the recommended steps that you can follow in order for you to do sentiment analysis. And then in part 6, you have to create a representation, okay, in terms of either you want to plot a line graph, scatter graph, histogram, okay, in relates in to the analysis of the article that you have done in part 5. Okay, so whether in part 5 you maybe in the steps you filter what are the stop words, okay, find out what are the positive, negative words, and so on and so forth, and then use some kind of use some string matching algorithm to find and delete those words. Okay, after you do that, plot the graph, whereby you may plot something like whereby in part 7, as you can see here, you can actually plot the graph to show how many positive, how many negative, how many neutral words, and maybe some other useful graph that you can plot based on the data that you get from your sentiment analysis. Okay. So again, you may find that inside this document, we have suggest what are the tools that you can use, but you can use other tools as well. Oh, for part 6, I think you have to you may plot whatever data that you get from part 5, which is the stop word, conjunction, preposition. Part 6, you do the comparison, okay, positive, negative, neutral. Part 8, you have to plot histogram graph, okay, of positive and negative words found in the web pages. Again, we suggest you use plotly. And then after that, in part 9, what you have to do is that you need to give some kind of conclusion, okay, in regards to the sentiment given by those articles. Okay, so if like let's say there are more positive words, you may conclude that the article is giving a positive sentiment, and vice versa. But then if you find any other if you want to use any other algorithm, maybe you want to find like positive over total number of words, to so that it will give you a more accurate sentiment analysis. By all means, please do by all means you can use that as well. Okay. And then, yeah, as I mentioned, you may try to conclude in different perspective as well. Okay. Whether like they are accurate and to be used in the context of article you extracted, and then you need to do a conclusion. Which of the courier company have the best sentiment? Meaning, in a sense, all the three articles, which one talks more positively about a certain a particular courier company? Okay, and in problem 3, okay, after you have done all the sentiment analysis and you come to the conclusion which courier company have the best sentiment, now you need to combine, okay, with that sentiment information that you get in problem 2. You need to include that as well to determine what is the best courier company um, that a customer can use. Okay, so in part 10, you can calculate the total probability distribution of possible routes. So again, how you calculate it, it's up to you. Okay, in terms of how you determine which courier service is the best to use. Okay. And then yeah, and then after that you have to write the summary. So maybe you want to have a rank like for each customer. Let's say, for example, what are the best, second best courier company to use, or in general, what are the courier company to be used. Like, let's say, for example, I don't know, maybe like if you have I'm so sorry. I'm having like can you hear me? Because over here there's some kind of construction going on. Can you hear me?
I can hear you.
Yeah, can.
Okay. All right. And then after, so basically, in the conclusion, it is up to you. Like, so let's say you want to make a conclusion. I don't know, maybe based on location. It would be better to use certain career company. So again, it's up to you. And use your creativity to write out a conclusion based on the data that you have. Okay, the distance as well as the sentiment analysis. Okay, so in problem 4 is where you will have to add in a new algorithm. Okay, so in this case, we have sort of like identify this dynamic time warping algorithm. Okay, whereby you can use this to analyze video or audio and identify some words. Okay, so in problem 4, here it is given a video, okay, a YouTube video, which contain words such as JNT, memohon, and maaf. So basically, what you have to do is to apply the dynamic time warping and see whether you can actually identify words. For example, the one that given here, which is JNT, memohon, and maaf. Okay. So, okay. So I will get back to you in terms of what you should do in problem 4. So for the timeline, week 4, you have to submit the group contract and filler form. So you have up until week 14, okay, to do this project. In week 12 or 13, okay, week 12 or 13, you'll be given some peer evaluation form that you have to fill up, whereby you are going to assess your members. And in week 13 or 14, or maybe 14 or 15, okay, for those groups that have a lot of group, like I think for me and Dr. Ajira, we have a big group. We are going to do a 30 minutes of system demonstration and presentation, okay, and then after that you have to submit a report you need to submit a report. Sorry, you need to submit a report. You need to submit your raw Python code as well as your second filler form. Okay. So in your report, you need to do a little bit of introduction, and then you have to do description. Okay, what are the tools that you use as well as the algorithm that you use to solve each of the given problem. And then if like let's say the string matching that you want that you're using in your implementation is not something that we covered in lecture, let's say for example, highlight the new algorithm, okay, because you're gonna get extra marks for using algorithm that is not that is not covered lecture. And I think for this question, if like in problem 4, you definitely will actually do a new algorithm, one algorithm that will not be covered in the lecture. So definitely if you like do something in for problem 4, you will get the marks for this one. You have to explain the running time complexity for each of the algorithm. All right. Okay, so yeah, so you also have to give a snapshot, okay, of the input output as well as the source code. Write a conclusion as well as any references that you do for your report. All right. So here are the assessment criteria. Okay, so you will be assessed individually, okay, in terms of your soft skill. So that's why each of you have to have to present something. Okay, so you have 30 minutes. There will be 5 or 6 of you. So allocate 5 minutes presentation for each member. Okay, whereby you will be assessed in terms of your presentation and what are your responsibilities based on the filler form. Okay. And then the group assessment, we are going to assess in terms of the algorithm. Okay, for the algorithm that you propose for each of the problem. Integration between items. So if you notice, each of the problem is developed individually, and in problem 3, you have to somehow integrate it. And then include new algorithm, okay, that is not taught in the course. So this is the bonus marks if you introduce new algorithm. Oh, yeah, and for problem 5, for problem 4, if you at least able to explain the concept of dynamic time warping, you may get up until 3 points. Okay, so if like let's say you are not able to implement the dynamic time warping, you will still get up to 3 marks as long as you are able to explain the concept of dynamic time warping within the context of this project. Okay. All right, so these are the group contract that you have to fill up. So all members have to do this. I believe like you have done this before for software modeling, right? So it's the same thing. You have to write up your group contract as well as submit your filler form by end of this week. So for my group, there will be a link to submit on Spectrum, as well as please put this inside your individual channel, individual group channel in the Teams. Okay. All right. So, do you have any question in regards to the project?
Doctor,
Yeah.
just a question. For example, like you were saying that there are extra marks for using like algorithm which are not being taught. So if we are not using a new algorithm, so is it like okay, you won't get the extra marks, or it will be like you won't get the 5% of the marks?
You will still get the 5% for solving the problem. It's
So like there
just that
won't be any negative
yeah.
marking if we don't use the new algorithm.
Yeah. I don't think it's very difficult to achieve because like to be honest with you, even when you how do you call that, you highlight the algorithm that you do for your conclusion, that is also considered something new. So but that you have to highlight the algorithm that you use to do the conclusion, the summary maybe perhaps, and the running time complexity for that one. Is that right? So it's not that difficult to get that extra bonus point for the new algorithm. Is that okay, Nabil?
Thank you, doctor.
All right. Any more question? Class?
Sorry, Doctor.
Yes.
Can I confirm about this? All code must be using Python, right?
Yeah.
So let's say I'm using JavaScript. That's not allowed, right?
You can combine, but please try to use for the main file. You have to use Python.
All right. Thank you,
Mm.
Doctor.
All right. Any more question? No.
Doctor, regarding the new algorithm, right? It's simply the algorithm that's not taught in the class, right?
Mm.
So it's not the algorithm that does not exist in the world that we have to
No.
create.
Then you will get a PhD. You can do that.
Thank you.
Yeah. Any more question? No? Yeah. So if there's no more question, I think that'll be all for project description for this semester. Okay. So Dr. Zina, anything you wanna say?
Okay, thank you, Dr. Azmiza, for the explanation. I just want to add, for example, the new algorithm we have learned string matching, like wrapping cup, try, so you can apply something else, string matching that is not taught in our class. That's also another way. And I agree with Dr. Asmiza. If you try to solve the third problem, right, definitely you have to create a new algorithm. So what you need to do during the presentation, you have to highlight this is the new one that you have created. Okay, that's all. Thank you. So I just would like to remind you on week 8 we have the online test. Okay. All right. So the further information we will be writing down at Spectrum. So thank you all. For L2, let's go to our class. Okay. Bye. Thank you, Doctor.
Okay. All right. Thank you, Karina. Thank you, student from L2. L1 still just you can stay here because we're going to continue with our lecture for today. All right. Okay, so that is for group project description. So for our group, I think all of you, I did not receive any more requests for assigning group assignment. Okay, so hopefully, I know that for the lab vivas, there are some of you that have to do the viva on their own because they were included in a group quite late. Okay, but hopefully for the group project, we are not going to have that problem. Okay. All right. So today we're going to be looking at another topic called the probabilistic analysis and randomized algorithm. Okay. So today you will see that what we are trying to do is a little bit different than what we have been doing so far, which is finding what is the running time complexity for an algorithm. Okay, so today you're probably going to see that what we're trying to do is to calculate the cost instead, okay, based on the input distribution for that algorithm. Okay, so the learning objective of is we're going to be looking at probabilistic analysis. Okay, so if you remember during school where you do, or is it, I don't know, during mathematics, one of your math subject where you do probabilistic analysis about, like what is the blue ball and the red ball inside a box, let's say, for example. Okay, so we're going to be doing something similar, but on to the input distribution, okay, of an algorithm. And then I believe we have looked at one randomized algorithm, which is the quicksort last week, whereby we sort of like do a little bit of analysis of the best, average, worst case for the quicksort. And you can see that quicksort is good because when you introduce randomized, it will basically enables you to get the n log n running time complexity, as long as you get some partition going on. So to get that is actually to have that randomized algorithm where you randomize the choice of pivot when you do the partition. Okay, so we're going to be revisiting this a little bit and see how we can do a much more specific analysis for random algorithm. Okay, and we are going to be doing this by looking at a problem called the hiring assistant. Okay, I'm going to be looking at the pseudocode probabilistic analysis and see how we can introduce randomized algorithm for solving this problem. And we are also going to be looking at all the statistics, whereby we're going to see how we can find maximum, minimum in linear time, as well as another algorithm called the randomized select algorithm and the select algorithm. Okay. All right. So, So for the probabilistic analysis, so as I mentioned, normally, if you notice, when we try to find what is the running time complexity, especially for what we did with quicksort, and then I think we did discuss this a little bit. Like, let's say, for example, if you are having a nearly sorted input, you may get to worst case running time complexity. So with this information, we can say that our the running time complexity for an algorithm often depends on what are the distribution of the input data. Okay, so and then as I mentioned, usually what we want to find, what is the best average case. So quicksort, we did do some kind of analysis of what are the best average case. So it can run up until n log n base 10 over 9. Okay, so if you remember the tree that we do last week, and best and worst normally rarely happen if we take into consideration, like not consideration as to how to avoid getting the worst case. Okay. So to reason about the average running time complexity for an algorithm, so normally we will try to know what are the distribution of the possible input. Okay, and then if, like, let's say there's some kind of randomization included in your algorithm, the analysis will be a little bit more complex, because like if like, let's say, for example, there's no randomization, that for each, you can actually calculate what is the cost for each of the execution of each code. Okay, but then if you have some kind of randomization, the cost is very difficult to be exact. The analysis, we cannot get an exact analysis of what are the running time if you have randomization inside your algorithm. Okay, and in this case, for any algorithm that implements randomization, you can actually use this indicator random variable. Okay, what we call the indicator random variable, or IRV, to analyze this kind of problem. Okay, so we're going to be looking at IRV today, which is analysis of algorithm that has some randomization. Okay, all right. So as I mentioned just now, up until now, what we have done is we calculate how many times a certain function do calls or loop in the algorithm of a specified input size. Okay, but for this topic, what we're going to do is we are going to calculate what are the costs of the specific input, and we are going to determine what are the probability of each of the elements. Okay, so please bear in mind the distinction about what we have done before and what we're trying to do today. Okay, I guess it will be more clear once we see the example. Okay, of what I mean by, instead of calculating what the cost of each of the like function calls or loop, and how do you actually calculate the cost for specific input, right? All right, so to do this, we are going to be looking at this hiring an assistant problem, okay, whereby the problem is actually about, like a company is trying to hire someone, okay, and it is using a job provider services. So it's like they have a list of candidates that they will give to a company to be interviewed, and if they feel like they are suitable for the role, they are going to hire that candidate. Okay, so so in order to so we're going to be using sequence of the candidates. Sorry, so we're going to be using this sequence of the candidates to represent the distribution of possible input for an algorithm. Okay, and then we're going to be using this to simulate the input distribution, and we're going to calculate the cost of interviewing and hiring the candidates. Okay, so let's say we have n number of candidates, and then the company will interview one candidate per day. All right. So if the candidate is better than the current hired assistant, the company have to fire the assistant and hire the new candidate. Okay. So in this case, there's a cost. There's a cost. Okay, for hiring, which we call it as CH. And the goal of this is we are trying to estimate what are the costs for this strategy. Okay, so it's a very simple strategy. The job agent, okay, will be providing a list a list of candidates, okay, a group of candidates for the company to interview, and then the company will interview one each day and hire the candidate if the candidate that they interview that day is better than the previous one or the current one. Okay. All right. So here are the pseudocode. So if we look at the pseudocode, we have one variable defined as bad. So this would be the dummy candidate, whereby when we run this, there will be one dummy candidate for this. Okay, and then we have the for loop, whereby we're going to loop through candidate from candidate 1 up until candidate n, and then we're going to interview each of the candidate, and then we're going to check if the candidate I is better than the candidate best, we are going to hire candidate I. Okay, so now I is going to be best, and we're going to hire candidate I and fire the previous one. Okay. So here, if you see, the cost of this model is not finding out what is the running time hiring the for hire assistant function. Okay, so in this case, we know that the running time complexity is probably going to be order of n, right? But this time, we are not going to, this is not what we're going to do. What we're going to do is instead calculate what are the costs. So we have the cost of hiring plus whatever cost of the for doing the interview as well, because later on you're going to see there's also a cost for doing the interview. Okay, so as you can see here, when we try to calculate the cost of hiring and the cost of interview, it will depend on what are the sequence of candidate that is going to be given to you to be interviewed every day, and how many times that you're going to hire out of that 5 candidates. Okay, so if like let's say so we have 5 days, right? So if like let's say 1, 2, 3, 4, 5 days, so you interview candidate 1, let's say for example. So now best is equals to 1, and then candidate 2 came in, and it is not better than let's say candidate 2 came in day 2, and it is not better than the best. Okay, so this is not going to be hired, this will still be there. So let's say on day 3 candidate 3 comes in, and candidate 3 is much more better. Okay, so now we are going to fire this candidate 1, and now the best is going to be 3. All right, so these are the things that we're going to be like try to calculate what are the costs for this strategy. Okay, are you good so far what we're trying to do? Any question regarding this? Yeah.
Okay. Okay.
All right, so okay, all right, so so then like now we know that strategy. So since all candidates must be interviewed, we are going to have a cost for the cost for doing the interview is unavoidable. So if let's say the company requires 5 people to interview, they have to pay that interview cost. Okay, so the CI is unavoidable. So but then the cost can be reduced based on how many times that you're hiring that candidate. So therefore, like you have to make sure that you the best cost is when you hire the best candidates in day 1. Okay, because the cost that will be incurred for hiring would only be once. Okay, so therefore what we're trying to calculate is that what are the expected costs of doing the interview of n candidates, and the cost of hiring some m number of candidates. Okay, and the hiring cost varies based on the input. So therefore, basically we're going to see the distribution of the sequence of the candidates that are going to be provided to the company, and we are going to focus on how we can analyze the cost. All right. All right, so what are the goals for the probabilistic analysis of this hiring problem is that we want to pay the cost for hiring the best candidate. Okay, so the best case is like I mentioned, we get the best candidate out of the 5 candidates on the first day. So in a sense, you only have to pay the interview cost for the 5 candidates, and only pay the hiring cost once. Okay, so that is the best case. This is what we want. But like it's very difficult for us to achieve this. And what we do not want is we do not want to pay the cost for hiring all the candidates. So in this case, okay, so how do we get this worst case, class? How do we get the worst case? Pay the cost for hiring all candidates. How can we get this?
if one is always better than before.
Right? So
Yes.
basically, what can you say about the input the input condition? How can what can you say about the distribution of the input? So if like let's say each of the candidate will have rank. So how what can you conclude in terms of the rank that will get you to
The
the
rank,
worst case?
rank is always
Sorry?
rank is always increasing. Is that
The rank is always increasing, right? So in a sense, every day a better candidate will come in. Okay, so therefore that can cause you to get the worst course. Okay, which whereby you have to pay for hiring all the candidates. All right, so meaning in a sense, your best candidates will be coming in at day 5. The worst, second worst, third worst, and then the best, yeah, on the last day. And what we're trying to at least achieve is that we want to get this average case, which we are trying to pay less for the cost of hiring candidates. Okay, so this is what we are trying to do. Okay, which is to get this average case. Okay, so for analysis using probabilistic analysis, okay, you need to have these two conditions. Okay, this assumption whereby we have an input chosen from a known probability distribution, and our input sequence is random. Okay, but the algorithm itself, please note that the algorithm itself is deterministic. Okay, it's just that the assumption on the input distribution, whereby again, as I mentioned, the input distribution, the assumption, we have to know the what are the probability distribution, as well as we assume that the sequence is random. All right. Okay. So as one of your friend mentioned just now, the worst case for this hiring problem is when we have to hire every candidate that we interview, whereby if like let's say the employment agency, okay, the agent sort of like try to cheat the company, and somehow they send the list from better from increasing order of quality. Okay, meaning in a sense, every day, like the candidate is better than the previous one, so therefore you're going to get order of NCH. Basically the cost would be, and the total number of candidates, and that will be the total cost of hiring candidates. Okay. All right. So how would you avoid this from happening? If like let's say the employment agency give you a list, so how can you avoid this from happening? Class? How you as the company can stop this thing from happening?
random?
You randomly call each of the candidates, right? So in a sense, if like let's say the company give you a list of candidates 1, 2, 3, 4, 5, instead of calling candidate 1 in day 1, candidate 2 in day 2, you random the list. You randomize the list. So maybe in day 1 you call candidate number 4, okay, or in day 2 you call candidate number 1, let's say, for example. So in a sense, you include some kind of randomization inside the list. All right, so basically by we tweak the hiring problem, we can actually avoid the worst case from happening. Remember, we did the same thing for our quick sort as well, right? So, but then if you remember, we don't really analyze quick sort very specifically. We sort of like have like some kind of intuition where we roughly draw the tree for quick sort. So for this one, maybe because the problem is a little bit smaller, so we are going to do probability analysis for when we have this randomization in our inputs. Okay, so how we can include random selection of candidates. So basically, if we do this, we are not going to make any assumption about the distribution of the inputs. Okay, the algorithm will have to include some random generator in order for you to randomize the sequence, and it may produce different output for the same input at different times. Okay, so if like let's say the input would be the list, okay, the list that we have that is given by the employment agency, but then because we have that randomization, even though we receive the same list, we are going to get a different output for that same list because we have that randomization. Okay, we randomize the sequence of the candidates to be interviewed. Okay, all right. So as I mentioned, in order for us to really analyze what is the cost or what for like for an algorithm that uses some kind of randomization, it is very complex. Okay, because you need to take into consideration all possible condition for each possible condition. Okay, so like let's say for example, again, if you look at the quick sort, in order for us to do the partition, so there's so many combination of partition that you can do when you run the algorithm, and you don't know how will the partition look like. So every time you run the quick sort, if you have that randomization, you wouldn't know how the partition is going to look like. Okay, so if like let's say, okay, you have randomization in your input, instead of looking at the actual running time, okay, how many times is the actual running time, okay, what are you going to do is that you're going to try to do some kind of try to find what are the expected running time for that algorithm. Okay, so in order for you to do this is like you're going to somehow convert it into probability, and then we're going to try to calculate what are the expectation, okay, for that based on the probability that you have identified. Okay, so basically what we can say is that when you do the probabilistic analysis, what you're trying to do is that you're trying to make an assumption on the distribution of the input. Okay, you're going to make an assumption, and then after that we're going to use what we call the indicator random variable to find what are the expected how do you call that, what is the expected running time complexity for that random algorithm. All right, okay, so here IRV, okay, indicator random variable, is a method for doing the conversion, okay, between the possibilities and the expectation as well as the vice versa, okay, of a random variable. Okay, so a random variable, normally we call it as X, is a kind of variable that will specify what are the range of probability distribution for that input. Okay, so in this case, so it's converting possibilities between expectation the range of probability distribution, and for the expected value of the random variable, and normally we call so this one we call as x, and the expected one the expected value of a random variable we call it as ex. Okay, so ex is the average value that we get from having a sample of a random variable that we do repeatedly. Okay, so basically this is what we're trying to find, which is the expected uh, 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 we cannot call it expected running time, maybe the expected cost, okay, for it to run. Okay, by doing some sampling of the random variable. Okay, and then for example, suppose we have a sample from space S, okay, and we have an event A, so we can write the indicator random variable IA that associate with event A as, so if like let's say you have event A, you can write it as 1 if A occur and 0 if A does not occur. Okay, so as I mentioned just now, probabilistic analysis is something that I believe you have looked into when during mathematics in, I don't know, maybe in your high school or in your matriculation. Um, you know, like if you have a box and you try to calculate what are the probabilities that you're going to pick up a blue ball or a red ball. Okay, so same thing applies here, but in this case we're going to be looking at event. Okay, whether if like let's say we are trying to calculate the event of, let's say we use the quick sort again, so the event of you know, like having nine sub partition, like one to the rest of the element after doing the first partition. So we are going to calculate how, what are the probability that that will occur. Okay, so that is an event, so we are trying to find out what are the probability for an event to occur. All right, so here are some lemmas that we're going to be looking at. Okay, let's say for example we have space S and an event A, and then we specify the random variable as xa. Okay, xa equals to indicator random variable A, and therefore we can say that the expected value of xa will be whatever the probability of A. Okay, so these are the lemma that we're going to be applying later in order for us to do the probabilistic analysis. Okay, so these are some proof of lemma 1. Okay, so remember these are the random variable that we have defined previously. So in order for us to find what is the expected value, okay, for event A, we can and the lemma say that the expected value for event A, okay, is the probability of A. Okay, so expected of the event of A, and if you expand it, it would be either 1 A occurs or 0 where A not where A not occurring. So not A. So here is not. So 0 where A is not occurring, and therefore you're gonna get the value would be the probability of A. Okay. So let's try to apply this on an example of coin flip. All right. So this is much more clearer because we know that coin flip, when you flip a coin, is either you get the head or the tail. Okay. So in this case, the space sample would be either we get the head or the tail, and we know that the probability of us getting head and the probability of her of getting tail would be 1/2, meaning half. Okay, so that would be the probability. So if you want to create the random variable xh, or the event where we get the head in each coin toss, we can write it as such. Okay, and we can write the random variable xh as 1 if you get the head, or 0 if you get the tail. Okay, all right, so now we can try to calculate what is the expected number of heads that we can get in one flip of the coin. So we can calculate that by using IRV, whereby the expected value, or the expected event that we get H, which is the expected of the probability of event H occur, we getting H occurring. Okay, and we apply this, which is 1 getting the head, plus 0 where you're getting the tail, and you put in what is the probability, because just now we know that probability of getting head and tail is half. So 1 times half and 0 times half, and we get the expected cost of getting the head is 1/2. Okay, so that is a coin flip for a single flip. So let's say, for example, we have a series of coin flip. Like, let's say, for example, we're going to flip a coin 3 times. Let's say, for example, what are the probability that we're going to get head and tails within that 3 coin flip? Okay, so it is the same thing. It's just that the way we define the random variable is a little bit different. Okay, so we can specify the x as the random variable for getting the head in n flips. Okay, so we're gonna so basically in the first step we're gonna break this x into smaller part, so we can specify the random variable for getting h in a single flip as such. Okay, xi. And then in second step we can say that the random variable x is the sum of xi for n flip. Okay, so if, like, let's say, for example, just now we got the expected of getting heads is 1/2. So therefore, in order for us to know what is the probability of we toss a coin and we got the head, would be the sum of the probability of each of the toss. Okay, so therefore we can specify the random variable for getting heads for all the 3 flips would be from I equals to 1 with up until n flips, and we're going to sum what is the probability. So therefore, we can calculate what is the expected value for x using the linearity of expectation. So we can say that the expected cost for getting heads, okay, for n flips would be the expected value that you're going to get by doing the sum of the probability of getting hits for all the 3 flips. Let's say, for example, our n is equals to 3. Okay, and using the linearity of expectation here, we can we can get this equation. Okay, we're going to put our e inside the bracket. We're going to get this one, and for this one, sorry, okay, so and then for xi, we have already calculated in the previous one, which is the single toss, and we got 1/2, right? We got 1/2, and therefore we can say that the cost the value for getting hits in some n flip some n flips, okay, is actually n/2, which is how many times that we're going to do the flip over 2. All right, so are you okay up until this point, class? Do you get the concept of doing the probabilistic analysis and random indicator random variable? Any question? Oh, you guys are still there. I always get feedback that this this topic is always like a little bit hard to like comprehend unless you look into several examples. Okay, so up until this point, what we are trying to do, we did we somehow look into this hiring and assistant problem. Okay, and we found out that we need to introduce a random, some sort of random approach to do the interview, okay, in order for us to avoid the worst case. Okay, and then we look into indicator random variable, because we're going to be using this indicator random variable to actually calculate what is the expected cost for, if like let's say we include the randomized list for our hiring assistant just now. Okay, so here what we are looking at is that we're trying to understand what is the indicator random variable first before we actually go back to our problem just now and try to calculate what are the expected costs for the algorithm. Okay, particularly using the randomized list. Okay. All right, so it's good, yeah, that you're still processing. So basically, that is what we do. We look at indicator random variable and how we applied it in trying to find what are the probabilities of getting the event of flipping coin getting heads in single flip as well as the end flips. And for the end flip here, as I mentioned, what we do is that we break it down into each individual flip, and in order for us to what is the expected value, we sum all the costs for each of the flip. Okay, each expected value for each of the flip, and in the end we get n over 2. Okay, so now we are going to apply the IRV for our hiring problem. Okay, so as I mentioned, for us to avoid the worst case is we randomly call the candidates on the list, okay, for the interview. So therefore, the randomized algorithm will take the list of candidate as the input, but the algorithm will randomly permute the list in order to generate the sequence of which candidate are to be interviewed each day. Okay, so basically what you're going to get here, okay, by having the randomized list, we are trying to create this n factorial permutation, whereby we assume that we gonna get equally like the distribution will be the permutation is equally likely when you do the randomization. Okay, so basically if you look at how the n factorial permutation, I believe you know what is permutation, right? So in a sense, if you have a set of elements inside, given a set of element, you can actually have different how do you call that, different sequence inside that array. Okay, so for the permutation, how do you calculate how many number of permutation that you can get? Is n factorial. Okay. All right, so this is the pseudocode for having a random list. Okay, so in a sense, the input will still be, so basically the input will still be the list given by the agency. It's just that here in line 1, you're going to permute the list of the candidates, and the rest of the pseudocode would be the same like the previous one. It's just that we're going to have one line here whereby we're going to random the sequence of the candidate. Okay, so now we are going to analyze the hiring problem, okay, using the IRV. Since we have some kind of randomization, we can use the IRV to do the probabilistic analysis. Okay, so let's say we have Xi to be the IRV that will associate ith candidate to be hired. Okay, and therefore we have our Xi whereby candidate I is hired. So we can write the indicator random variable as 1 if the candidate is hired, 0 if the candidate is not hired, and we know that our X would be the expected cost for candidate 1, candidate 2, up until candidate N. Okay, so you remember we have 5 days, 5 candidates. So therefore, in order for us to know what is the whole cost, the whole expected cost, we need to consider what are the expected costs for each of the candidate. Okay, and then we know that the expected cost for hiring candidate I is the probability of candidate I is hired. Okay, so in this case, what is the probability of candidate I is hired? Class? Okay, so the probability would be, if let's say we iterate, okay, candidate 1 through I, we can assume that the probability would be of it to be hired would be 1 over I, right? Meaning, in a sense, if you are if let's say the list is randomized and the probability of that candidate to be hired in the on one of the days would be 1 over I. Okay, and then we can continue doing the analysis of the hiring problem using the IRV. So basically, the total cost would be what are the sum of the probability of each of the candidate to be interviewed and by the company. Okay, so in that case, we know. So basically, we can write what is the expected value for the candidate to be hired to be the expected of the sum of each the probability of each of the candidate to be hired on a particular day. Okay, and by applying the linearity of expectation, we can say that the expected value is the sum of the expected value for each of the candidate. All right. So in that case, it is the summation of I 1 over I up until N, and therefore, if this is actually a harmonic series, so we will get log N plus order of 1. Okay, the cost. Okay, so basically we can say that the expected cost would be this. All right, so are you good so far what we're trying to do? At least you grasp the concept first for now of how we can use the indicator random variable. Okay, are you all good? Still processing. Right, are you okay? So maybe you're gonna have more question during lecture. Sorry, during tutorial. All right. So we did mention about permuting an array, meaning try to get the array to be to have a different sequence even though you have the same set. Okay, so there are several ways on how you can permute an array. Okay, so so normally as you can see here, many of the randomized algorithm permute the array by because what they want to do when they do the permutation in the onto the input array is so that they will get the uniform random permutation, where what does it mean by this is that each of the n factorial permutation must be equally likely. So let's say for in this case, let's say for example, we have 3 chairs and 3 people, people, and basically the permutation, we can say that for the first chair, there are 3 people. There are 3 likely people to be sitting on that chair. And then on the second chair, since one is already be assigned on this chair, so there's only 2 possible people left to be sitting on the second chair. And lastly, on the third chair, there's only 1 person left, okay, for sitting on this chair. So that is what it means by uniform random permutation, and they are equally likely to be sitting in any of the chairs. Okay, so that is what it means by equally likely. So another example, uh, let's say we have this array 1 until n, and this array can contain some permutation 1, 2 up until n. And basically, if you do randomization on this initial in this array, the initial order will make no difference. Okay, so in a sense, the sequence of the sequence for each of the element to be processed will not be determined by the order that of the input array. Okay, so basically when you want to do the randomization, you will have some kind of random number generator. Okay, so your randomization, how good is your randomization, will depend on your random number generator. Okay, so for example, you can have a function random AB, where this function will produce a number between A and B with the probability of 1 over B minus A plus 1. Okay. All right, so there are 2 methods, generic methods on how you can permute your array. One is you can permute it by sorting. So how do you do this? Is let's say you have each element in AI, you're going to generate a random priority value, whereby the range should be 1 until n to the power of 3. Okay. And then after that, you will sort the array into an increasing order using the priority value as key, and then output the sorted array A. Okay, so this is the pseudocode. All right, so it's a very simple pseudocode. It's like you have your element, and then you have an array, and then you have another array, and then you're going to sort A using P as a sort key. So for example, you have this array. Okay, so you see that your array A is an increasing order, and then you're going to generate a priority array, okay, where it contains some priority value. So you're going to get 30 for index 1, 9 for index 2, 53 for index 3, and 7 for index 4. And then you are going to sort this priority key, and it will result in permutation, whereby you're going to get, so the smallest is this one, so you're going to get 4. Now element 4 is going to be processed first, and then element 2 is going to be pressed next, and then 1 is going to be processed next, and finally the 3 is going to be processed. Okay, so that is how one of the way that you can do the permutation. whereby you create some kind of priority key, okay, for each of the value. Or you can also do it in randomized in place, okay, whereby it will permute the given array in place, and basically the AI will, the element I in array A will be chosen randomly, and after I iteration, the array will not be altered. Okay, so here are the pseudocode. So what you have to do is that you have the n element, uh, and then for each of the iteration, what you're going to do is that you're going to swap AI with some random element in the array. Okay, so I think this is what we do for I think one of the example that we use in the quick sort, right? Which is a randomized in place. All right, so up until this point, are you good so far, class?
Honest answer, probably not so much.
Okay, maybe I know because from my experience, normally in probabilistic analysis is a topic because this is where you sort of like change a little bit. We have been learning on how we are going to calculate the running time complexity based on the algorithm. But for this topic, we are not looking at the algorithm specifically. We are actually looking at the input that is going into the algorithm. So, that change of perspective is quite confusing in the beginning sometimes. So, we'll try and see if, like, let's say, you have any, if you need further clarification, we can discuss this during tutorial. Okay.
Okay.
All right. Do you want to take a break? We have all the statistics, so I think we have like around 15 slides left. Do you want to like continue and try to finish it like 15 minutes sooner, or you know, like you want to continue? You want to take a break? Finish? We continue and then we finish early.
Continue. Finish
We
early.
continue.
We'll just take a look back at the slides. Slides are in the drive.
Yeah. The slides are in
Yeah.
the drive. Yeah.
Okay. Yeah,
Okay.
continue.
All right. So up until now, we have looked into the indicator random variable and how we can do the analysis, the probabilistic analysis when you have randomized some kind of randomized algorithm, and we also look at how you can do the input permutation. Okay, the two method on how you can do the permutation of your array. Okay, so next we're going to be looking at order statistic. Okay, so this is a little bit different from what we have looked until now. But in order statistic, it applies some kind of randomized algorithm. Okay, it contains randomized algorithm, and we can, you know, and we use probabilistic analysis to try to calculate what are the expected costs for the algorithm. Okay, so here we are going to go back into trying to find what is the expected running time complexity for that algorithm. Okay, based on the distribution of input that we're going to get for that algorithm. All right. Okay, so hopefully you're following me. Okay, so order statistic. So basically, when you talk about order statistic, and if you are trying to get what is the ith order statistic of some n elements, is the ith smallest element. Okay, so like let's say for example you have an array, and let's not make it big, maybe 5. So we're gonna have 1, 2, 3, 4, 5. So this is 0, 1, 2, 3, 4, right? Your array. Okay, so in order statistic, if you want to find what is the third smallest element in this array, where is that element, where in the array that element is, it would be element. So if like, let's say, okay, now I think my brain is a bit fried today, and it's the first day of puasa, so uh, um, so yeah, so I can feel myself that my brain is a little bit like jumbled up. Okay, so let me rephrase it again. So if like, let's say we have this array, right? And this value inside this array A. Let's say the question is, what is the okay, maybe I will start with what is the smallest value in this case in the array.
It should be 1.
It should be 1 in index 2,
Index 2.
right? All right. So let's say, for example, we want to find what is the fourth smallest element in the array. It would be 4 in index 1, right? So order statistic, so basically that is what order statistic is. Okay, so you want to find what is the ith element in a specific in some given array. So what we're trying to do is that we're trying, so okay, but before that, so for example, as I mentioned here, in order for us to get what is the minimum of the set of element, basically it would be the first order statistic, and the maximum would be the I, whereby I is equals to n order statistic, provided that the array is sorted. I should have said this one. Provided that the, for example, okay, so no, I don't think so. They are not asking for the index yet, right? So is just like asking if, like, let's say, what is the first order statistic? It will be I equals to 1, and the maximum would be the biggest element inside the set, okay? And then for a median, we specify it as halfway point of the set. So if, like, let's say you have n, so if if your n is odd, you can easily find what is the median, which is n plus 1 over 2, and you will get, so let's say, for example, for this example, so we the n is odd, so we know that uh, 5 plus 1 over 2, and we know that the median would be 3. Okay, so somewhere, if, like, let's say, for example, this array is sorted, the median would be in array, in this array, because so if we say that, so 0, 1, so this would be 1, 2, 3, so this would be the median. The median array, but not the median value, because we haven't sorted. So this one, if you want to find the median, we assume that the array has been sorted. Okay, and then if, like, let's say we have an event, so the median can occur at two places, either at n over 2, or at n at n over 2 plus 1. So we can say that the lower median would be n plus 1 over 2 floor, okay, or the upper median would be the ceiling of n plus 1 over 2. Okay, so these are the two median if the number of n is even. Okay, because the median can occur at either the lower median or the upper median. Okay, so for example, if, like, let's say you were given this element, okay, this array, if, like, let's say you were given this array, how would you find what is the third smallest element inside this array? Class, what would you do?
Look for the. Wait.
If, like,
Check
let's
one
say
by
you
one.
want to find, check? How do you check one by one? How do you check one by one? Guys? You probably gonna sort it.
Oh,
Oh, so you sort it first, and then you
and then
You find the third, what is the third element, right? So that would be how you would do it naively, like you will sort it, and if like let's say I want to find what is the third smallest number in the array, you will just return I3 or AI4 AI4 if like what it would be zero sorry A2 because 0, 1, 2, right? So you want to find what is the third smallest element inside the array. So you're probably going to sort it, and then so maybe it will be much clearer if I just like straight away draw. So 1, 2, 3, 4. So now if I sort the array A, I will get 1, 2, 3, 4, 5. So in order for me to find what is the sort the first three elements, if you sort the okay, maybe I'll continue this one first. I get distracted by the question. Okay, so if like let's say you sort it and then you find what is the third smallest element, it would be you find out this is 3, right? Okay, so one of your friends said you sort the first 3 element, you're just going to sort this one 2, 4, 1. You're not going to get 3. Until the first elements are in the sorted order. Because right now you have no idea how, if like you will still have to sort it until the end. You still have to go to up until order of n sorting. You still have to sort all elements first before you can be sure that the first 3 element is already sorted. What if like let's say for example, so in this case where are you going to stop? If like let's say you're going to stop here, you still have 3 to be sorted inside here. Do you get what I mean? So you still have to sort and then finally get what is the rank for the I smallest. Let's say for example. All right. And then for the maximum, um, um, so you're doing insertion sort. You're somehow so basically you're trying to do the insertion sort. You're actually sorting. Yeah. Right. So you are doing the sorting. Okay, so meaning in a sense you get the smallest and then you use that as comparison, right? So basically in so you will the running time obviously will be order of n. Yeah, you can actually do that as well, I believe. Okay, and then for the minimum and maximum, you can do comparison. Okay, so same goes as that one. How but can you do that? Smallest, the second. Oh, so basically you will determine the for loop, right? So so if like let's say you know that it will run up until 3 times for if like let's say yeah, I think you can do that. Okay, and then all right, so for the minimum and maximum, how many comparison necessary to determine what are the minimum set of n elements? So basically what we can do is that we can do the comparison and we can return the mean. Okay, so same goes for the max. So it's very easy. So you have to do so all you have to do is do the comparison. Okay, but then for goes back because this one the running time complexity would be order of um order of order of n, right? And then if like let's say we want to find the third element for so it can go up into order of n squared, right? So if like let's say I think Gori proposed that you get the order of mn, yeah, almost like order of n squared, or meaning in the times you basically, if like let's say your m is 3, then it will times 3. But what if you want to find the maximum, then it would be order of m, almost n squared. All right. Okay. So, okay, so in this case, what if we want to find the median or any other element in the rank? So either you do what I think Gori did suggest in the chat, try to sort the maximum number first. So the running time capacity will still be some half n times n. It will still, the running time complexity will still be up until n squared, right? If you want the maximum, yeah. I mean, it will still be if like your m, it's like let's say m is the length of the, yeah, I know, yeah. So basically, it will still be almost n squared. The time would still be, the running time complexity will be still be almost n squared. Yeah. Okay, so in the algorithm that we're going to be seeing later, it will run much better. Okay, because you do not have to actually go or like run it up until m. Okay, at least m. So in your algorithm that you mentioned here, the for loop may run up until m times. But the algorithm that we're going to be looking at later, this selection the selection algorithm, it can because it has some randomization, so the probability of the runtime complexity will be much better. Okay, so like let's say it goes back to our question here. In this case, the running time is order of n. But what if we want to find median or any other other element rank in the array? We can do this randomized select, where we can run this element. We can run this algorithm in expected linear time. So our expected linear running time complexity, we can expect it to run in linear time. Okay, so this is much better than order of n times m, whereby it will still be depending on what is the rank that we want to find, right? So the randomized select is not something new. We have looked it in our quicksort, okay, whereby we do the partition recursively in our quicksort. But in randomized select, once we find the pivot, after if you remember inside our quicksort, by end of the each recursive calls, each recursive operation, you're going to get the element in its correct position, right? So in the correct position, and you know what is the rank for that element. Okay, so if like let's say we have this partition, and after uh and after uh after after one recursive operation, we're going to get our x value. So let's say, for example, our x value in the correct position. So therefore, we know what is the rank of this element. All right. So for randomized select, so let's say, for example, we want to find maybe, so basically, let's say, for example, our array A will have 10 elements. So n is equals to 10. Let's say, for example, we want to find I equals to 4. Let's say, for example, right? And then we apply the partition. Okay, we recursively do the partition. after each of the recursive call, we know that this would be, of course, this one would be smaller than x, this one is bigger than x. And let's say, for example, this x is in position in index 6. Sorry, maybe let's put 5. Maybe x is index 5. So in randomized select, you can already eliminate this one. So you do not have to do you do not have to search for this array anymore. Okay, so this subarray you can already eliminate. So all you have to do is just do the partition again and try to find I is whereby I is equals to 4. Okay, so do you see the concept here? So it's not something different. It's just that we're trying to use the partition concept in quicksort, but to find what is the ith rank in the array. Okay, and but basically after each iteration, we only choose one subarray instead of the two. When we do in quicksort, we only choose either we want to find it in the lower subarray or the upper subarray. Okay, so this is the pseudocode for randomized select. So basically, you do the randomized partition, and then you're going to get the k. So if I is equals to k, if the pivot is in the position equals to I, and then the value is a q. Else, if I is smaller than k, you will do the partition in the lower subarray. Else, you are going to do the partition, the randomized select on the upper subarray. Okay, so it's pretty simple. But for the analysis of the randomized select, it's a little bit different because since we have the randomization there, we have to apply the indicator random variable, okay, in order for us to do the analysis. Okay, so so basically we assume that the randomized partition is equally likely to return any element as the pivot, and therefore we can say that for each search k, so whatever it is, so that we can say that each of the element inside the array have the probability of 1 over n to be selected as the pivot. Okay, so therefore we can write the random variable xk, where the subarray of apq has exactly k element. And so assuming that all elements are distinct, we can say that the expected value for the subarray PQ has exactly the k elements is 1 over n. Okay, so basically the randomized select, like as I mentioned, the size of the subarray, maybe, like one would be smaller, one would be bigger, and one would be bigger, and one would be smaller. But then for the randomized select, only one subarray would be selected. So we can say that, so these are, I'm not going to be going through this very specifically, but basically what we're seeing here is that we are trying to define that possible probability. So probability of having what size of subarray for the next partition. Okay, so therefore, so we can say that the expected values for this would be 1 over n, and the maximum of k minus 1 and minus k. So basically the size of the subarray, the combination of the size of the subarray plus order of n. Okay, for the size of the element. So again, I don't think I'm going to go through the analysis. Maybe not now. I think everybody's brain is fried. Maybe if maybe I would like try to see whether I can create a video for explaining how we write the random how we apply the random variables for this the analysis of randomized sort randomized select. But basically here we can say that after applying the probabilistic analysis on the randomized select, okay, so if you apply it properly, you will get the expected cost for the randomized select would be order of n. Yeah, you sort of like guessed it correctly. Having a bad caffeine withdrawals, yes. So do I. Okay, so basically here, after we do we apply the indicator random variable, we can see that the randomized select will give you the value of will have the expected linear value. Okay. All right. Okay. All right. So when we talk about the selection in worst case linear time, again, like for the selection algorithm, the running time, it can go up until order of n in the worst case. Okay, whereby like basically how you do the partition how you do the partition, you're gonna get every time the partition somehow will give you the like it will keep filling up 0 to the rest of the sub element. But then a good split can be guaranteed upon partitioning the array by doing the randomization. Okay, select uses deterministic partitioning algorithm from quicksort, but modified to take the element partition around as the input parameter. Okay. And then there is another one called the select algorithm. So it's a little bit different. It's not different, but it's still taking this the same concept as the randomized select. But in this case, it groups the element into it groups the element into several groups. Okay, and then it will try to find the median of each of the group and the median of the median. I hope that I'm still making sense to you. Okay, so maybe I will just straight away show you this picture. Okay, what is happening here is that if, like, let's say we have 1 2 3 4 5 25 26 27 28. Okay, so let's say for example we have our n is equals to 28. Okay, in this select algorithm, what you're going to do is that you are going to group the element into 5. Okay, so we're going to have one group here, okay, of element. Maybe I would instead of using pen, I'm going to use highlighter. So we have this group, one group, two group, three groups, four groups, five groups, and whatever the remainder into this group. And then what you're going to do is that you are going to find the median of each of this group. You're going to find the median of each of this group, okay, the orange group. And then after that, after you find all the medians for each of this group, okay, so like let's say the median is this one. These are all the medians. All right. You are going to find the median of the median. So in this case, the median of the median would be, so like let's say we find the lower median, since there are 6 elements of medians. So we're going to select this as our median. From here, we can say that whichever elements, maybe I will use yellow, whichever elements, maybe not this one. Let's find something, maybe like, let's use pink. Is pink nice? So we can say that whatever elements in this group would be smaller than X. 1 second. Oh, where is it? Oh, this one is okay. Oh, where is my, sorry. So for okay, so whatever element that is inside here would be smaller than X, and whatever element, sorry, whatever elements that is in, sorry, whatever elements that is inside this would be bigger than X. Okay, so therefore in order, so basically from here you can see that you sort of like able to eliminate a number of elements that you do not have to look at. Okay, so this algorithm, if you do the analysis of it, you will get that the worst case for this select, okay, recursively at most 7n/10 plus 6 elements. Okay, so these are the only element that they're going to visit in order for them to look for what is the order statistic for the element. Okay, so again, I'm not going to be going through with you in terms of how you calculate the elements. So but basically, based from how the algorithm is performed, you can clearly see that you do not have to like search almost uh like 2/3 or 3/3 sorry uh 3/4 of the element. You can actually eliminate it. That's why you get the like 7/10. So you can at most on up until 7/10. If let's say you have you are applying this algorithm to search for the order statistic of an element. All right. So we can say that the worst case running time complexity for this one would be linear as well, which is 7n/10 plus 6 element. All right. Okay. All right. I think for this topic, it's a little bit I would say it's more of a concept, okay, rather than the application itself. So try and have a look at it. If you have any question, we will continue the discussion during the tutorial. I think the tutorial question is already up in Spectrum as well. Okay. And then, okay, so is it like binary search with quick sort? Yeah, almost like you're doing the binary search with quick sort. Yeah. So basically, binary search, you do eliminate one part of the subarray, but in this case, since we don't like fully sort the array, it's just that we generally know that the upper subarray is bigger and the lower subarray is smaller, and we eliminate. Yeah, you can say that it is almost like what the binary search algorithm. Okay. All right. So before we end our class, any question? I thought I can end the class early. Any question, class? No?
So basically, it's like you take, if we use like the quick sort aspect here. So we do the quick sort, it's sorted, and then if it's not the thing we're looking for, we identify if it's bigger or less than the point we're using, and then if it's like less than, we completely ignore the greater than aspect, and then we just look at all the values that are less than. We choose another value as like a pivot, pivot. Then we do the thing, and then if the pivot isn't it, then just keep repeating until you actually hit the one that we want to find.
Yeah.
Okay.
So it's just like the quick sort, but you're not really sorting. You're just using the information of the pivot location after each of the recursive calls, and then you eliminate. So if like let's say the order statistic is lesser than the order that you want to find is lower, you search in the lower subarray. If it is bigger, you search on the bigger subarray. So you already eliminate almost like, provided if your pivot is right smack in the middle, you basically already eliminate half of your of the array.
Okay.
Okay. All right.
Yes.
Okay. Any more questions, class? No. So if you have any question, try to do the tutorial first, and then we will continue our discussion during tutorial. Okay.
Okay.
All right. Okay. Thank you very much, everyone. Bye.
Thank you,
Assalamualaikum.
Doctor.
Have a happy fasting to those who are
Oh yeah.
fasting. All right.
Thank you, Doctor.
Bye. Assalamualaikum.
So yeah,
Thank you,
Doctor,
Doctor.
Fila submit like Monday
Oh,
or Sunday?
submission like for me, for my group, I give it until Sunday. Yeah, until Sunday.
Okay.
Okay. All right. Bye. Assalamualaikum.
Salam.